Hello there. Let's look at problem 57. Insert interval. You are given an array of non-overlapping intervals, where intervals I equals start I, comma, ni. Represent the start and the end of the I interval and intervals is sorted in ascending order by start I. You are also given an new interval, start, comma, end that represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start I and intervals still does not have any overlapping intervals. Merge overlapping intervals is necessary. Return intervals after the insertion. Note that you don't have to modify intervals in place. You can make a new array and return it. Great, thanks. I'm just thinking about. Let me read the problem to make sure I understand it. You are given an integer of non-overlapping intervals. So we are given non-overlapping array called intervals. Intervals is represented as start of I, comma, end of I. Intervals is sorted in ascending order. Ascending order by start I. You are also given an new interval that represents the start and end of another interval. Insert interval into intervals such that intervals is still sorted in ascending order by start I. Sorry, give me a second. Okay, let's get back to here. Insert interval, new interval into interval such that interval is still sorted in ascending order by start line, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Okay, so the keyword here is non-overlapping and then ascending order by start line. So those are two properties that we need to maintain in intervals. Return intervals after the insertion. Okay. Now let's look at example 1. We have let's see over there. We have 1, 3 and 6, 9. So the new interval is 2, 5. So I think we are gonna insert this way by 1, 3, and then we will have 2, 5, and then we will have 6, 9. Oops, got it wrong. We need to merge this into 1, 5 and 6, 9. Okay, example 2, we have 1, 2, 3, 5, 6, 7, 8, 10, 12, 16, and then we want to add 4, 8. So I'm gonna insert this into there. So when we merge it, we will have 1, 2, and then 3, 4, 5 is combined until 10, then 12 and 16. So is that correct? We have 1, 2, 3, 10, 12, 16. Correct. Good. Just thinking about what else could be relevant to know here. May I know the length of the intervals? So you are given the length is between 1 to 10 to the power of 4. And I think that's all that we need to know. Perhaps the range of start and end. So range of start and end. So it's given by between 0 and 10 to the power of 5. I guess that's all that we need to know. Yep. I think I understand the problem now. Let me think about some possible approaches. I will now consider possible approaches. So from the example above, just 1 second. Because we know that the intervals are all non-overlapping, then Basically, what we could do is, off the top of my head, I think we could look through the intervals. Just give me 1 second. So what we could do is that we look through the intervals and then we go through each one of them, but we keep note that the new interval that we are going to add. So if we see that the new interval start is less than the current interval that we are considering, then we take it and then we check the end. We compare it with the current interval that we are looking for. And then we take whichever is the later one. Sorry. Actually, let me think for a second. So I'm thinking of the possible scenarios here. So I think there are like it could be before, or it could be the new could be before the current interval that we are considering, or it could also it start before but it ends in the middle. Oh, of the current one that we are considering, of the old one, let's just say. Or it could be the new one. It start in the middle of the old one, or it could be one of the interval is inside the other interval. Or okay, so I think it doesn't matter whether it is an old one or a new one. So just give me 1 second again. Okay. So I think there are a few cases that we can consider. Let me write down some notes here. Uh, case case one, non-overlapping. Case two is it could be overlapping. But not, how do I say it? I'm just gonna use the word covered. So covered means that A is all in like B. And third, A could be covered. Right? Okay. So I think this would be the scenarios that we need to consider. So in case one, if it is non-overlapping, then what we are going to do is we will add float to interval. In case if it is overlapping but not covered, then what we're gonna do is we take and we are gonna add a new interval, which is the start would be the then it should be the minimum of start, and then the end would be the maximum of end. So that if we do so, then we basically merge this interval into one interval, and then we take the start and end to be the largest, so that both original intervals are covered in the by the new one. And then covered, I think we can do the same, right? Yeah. So I think right. I think there's other cases here. So non-overlapping, it means that. So how do we check whether there is overlapping or not? So what we need is um, the end has to start. Okay, so I think there are two cases of non-overlapping. Start one is less than, sorry, not start one. So two cases are A and one is before. Okay, it just occurred to me whether the overlap. Okay, so overlapping means that start and end could be the same. So if one interval end at x and then another interval start at x, then those two are considered overlapping. Got it. be the n2 is less than start 1. So I think what we're gonna do is that we go through each of the intervals and then we check whether it overlap or not. If it doesn't overlap, then we basically add both of them to. I think we can add the one that ends earlier so that okay. I think here's what we're gonna do. So step. So first one, if ni is before start, then we add intervals I. Otherwise, if the n, sorry, how about it start before it? So if n is before the start of I. So here what we're gonna do is we add the new interval plus remaining. So we add the new interval and then we add the intervals from the current one towards the end. Otherwise, we set the new to be the minimum of start and start I, and then the maximum of n and I. Okay, cool. We put it here. So does this sound reasonable to you? I think it's better to just check with our example and then go through the logic there. So let's look at example 1 again. Now we have our new one is so we have new, which is 2 5, and then we have interval of I. So here, interval we have 1, comma 3, and then we check that don't forget the output. So the n 5 is not before 1, and then 3 is not before 2. So this one is there is an overlap. So what we're gonna do is we take the minimum and then we create the new one as 1, comma 5. And now we see the new interval, we have 6, comma 9. In this case, this is not an overlap. So we add them to the output. So 1, 5, and 6, 9. Then after this, we just set the new to be empty. Can we do that? We just set it to none so that we don't add it again in the future. So after the loop, we are going to check whether we have added or not. Okay. Now let's look at example 2. Again, we have new, which is for 8. Then we have interval. Then we have output. Interval, the first one is 1, comma 2. This one is not overlapping, so we add 1, 2 into the output. And then we have 3, 5. 3, 5 does overlap with that. So we are gonna take the minimum of start, which is 3 and 8. And then we will get the next interval, which is 6, 7. 6, 7 does overlap. Again, we reset the new into 3, comma 8. And then the next interval we have 8, comma 10. Again, it overlaps, so we take it to 3, 10. Now we see 12, comma 16. In this case, we add both of them into it. Then the new is now none. Okay, so I'm pretty good about this. We'll proceed to programming unless there is a further optimization that you would like me to explore. Great, I think it is good enough, so I will start implementing this. But before that, just give me 1 second. Alright, so how are we gonna implement this? Um, so I think I can just start with creating an output list. So here I create an empty list. Output initialized to an empty list. Then I'm gonna look through the interval. So for interval in intervals, I'm gonna check if new interval, just call it new here. So if the new interval, if there is a new interval, then you're gonna check um, if interval of 1, sorry, the n has to stop. Okay, interval of 1 is before the new of 0, then we add it to the output that append the interval. Otherwise, if new of 1 is before the interval of 0, then we append the new. Actually, let's just use this 10 here. So output dot extend the new and the interval. Now don't forget to set the new to none so that we don't add it again in the future. Else, we need to set the new into merge to a merge interval. So this would be the minimum of new 0 and interval 0 and would be the max. Let's actually just give me 1 second here. So the n would be the max of new 1 and interval 1. Okay, I think that would be it. And then if it is possible that we have added new, if that is the case, we just add the interval directly. So I'll put that append interval. And then outside the loop, we also need to check if new, then we basically need to append the new. Then we return the output. Okay, let me quickly go through the code to make sure I don't miss anything. First of all, I have output list, and then I will go through all the interval. I will check all the cases there. First of all, it could be the interval ends before the new one, so I add it into the output directly, and then move on. Else, it could be that the new interval happened before the current one. So I add it first, and then I add the current interval and move on. But before I do that, I set the new to none so that I don't add it again in the future. Otherwise, I will create a new interval out of these two, which is basically a merged version of the new one and the current interval that I'm considering. Otherwise, if there is no new, then I just append it into the output list. In the end, there is a possibility that the new is not added yet, so in this case, I just add it towards the end. Then I return the output. Alright, great. Let me test the code with this input example that we have here. So example 1, we have interval 1, 3, then the new is 2, 5. We see that they overlap, so we create a new one. Then we check the next interval, which is 6, 9, and the new one happened before the current one, so we add it into the output, and then we add the current interval. Sorry, just give me 1 second. Right, so I think it works. Example 2, we have same thing. Yeah, I think it works. So let me try to put our solution into LeetCode. Let me run this. New is not defined. is not defined again, should be new interval. Yep, we got it right. Let's try to submit this. Got wrong answer. So interval is 0. Okay, so we append the wrong thing there. Oops. Yep. Got it right. Yeah, I think that's about it for this problem. Let's look at some of other solution, just in case. So let's append and while I less than n, interval I before then the min and the max. Okay. Right. I think this is the general solution of it. It is much cleaner this way. But again, the logic remain the same. So this one is using sort. So I think this is could take much. Complexity-wise, this is much more. This is a bit slower than what we did. Let's look at some more. Yeah, I think this is much more similar to what we are doing. Alright then, I guess we are good here. Thank you everyone.